Dear students, in the previous classes, we have explained the derivation of wireless estimators using matrix algebra in the k-variable model. Now let me clarify a few more points in this context, as this will be useful when we study the problem of multicollinearity in detail. Now, the k-variable PR was written as y is equal to x beta plus u. Its sample counterpart is x beta hat plus u hat. And the normal equations applying the principle of wireless is x transpose y is equal to x transpose x beta hat. The normal equations in the general k-variable model. And beta hat vector is x transpose x inverse x transpose y. Now let us clarify some points about the normal equations and also the wireless vector beta hat, as this will be useful later. Now suppose that we have a two-variable model. Ya is equal to beta 1 hat plus beta 2 hat xi plus u hat plus u hat. The normal equations for this two-variable model is sigma Ya is equal to n into beta 1 hat plus beta 2 hat sigma xi. Sigma Ya xi is equal to beta 1 hat sigma xi plus beta 2 hat sigma xi square. So, for the two-variable model, the normal equation is this. So, naturally, it follows that x transpose y is equal to sigma ya xi, and x transpose x is equal to n sigma xi square x transpose x into beta hat, beta 1 hat, beta 2 hat. This will give you n into beta 1 hat plus beta 2 hat sigma xi and beta 1 hat sigma xi plus beta 2 hat sigma xi square. Now as you can see, x transpose y is equal to x transpose x beta hat sigma ya xi. So sigma ya is equal to n into beta 1 hat plus beta 2 hat sigma xi. Sigma ya xi is equal to beta 1 hat sigma xi plus beta 2 hat sigma xi square. So the normal equations for the two-variable model is this. The two-variable model was also presented in deviation form as Ya is equal to beta 2 hat sigma xi plus u hat I. In deviation form, the two variable model is this. And the normal equations in, yi is equal to beta 2 hat xi plus u hat I. And the normal equations in deviation form was sigma yi xi is equal to beta 2 hat sigma xi square. Then x transpose y in deviation form is equal to sigma yi x2y is a scalar, and x transpose x in deviation form is sigma xi square. Then x transpose x beta hat is equal to beta 2 hat sigma xi square. Then if I add beta 2 hat here, it becomes beta 2 hat sigma xi square. So in deviation form, this is the normal equation. There is only one normal equation in deviation form. So this is the correspondence between the normal equations in matrix algebra and the usual ordinary algebra. Now let us see the three variable model. The three variable model. Now the three variable model is yi is equal to beta 1 hat plus beta 2 hat x 2y plus beta 3 hat x 3y plus u hat. And the normal equations are sigma yi is equal to n into beta 1 hat plus beta 2 hat sigma x2y plus beta 3 hat sigma x3. Then sigma yi x2y is equal to beta 1 hat sigma x2y plus beta 2 hat sigma x square plus beta 3 hat sigma x3y x2y. And sigma yi x3y is equal to beta 1 hat sigma x3y plus beta 2 hat sigma x2y x3y plus beta 3 hat sigma x3y square. The normal equations for the three variable model. Now as you can see, x transpose y for the three variable model is sigma yi x2y sigma yi x3y. You can practice it by multiplying y with the x transpose. You will get this vector. Now x transpose x is equal to, it's a 3 by 3 matrix, n sigma x2y sigma x3y sigma x2y sigma x2y square sigma x3y x2y, then sigma x3y sigma x2y x3y sigma x3y square. It's a 3 by 3 matrix with the diagonal elements are squares and off diagonal elements cross products. As we have discussed earlier, it is a symmetric matrix, square symmetric. And if you multiply this with the beta hat, beta 1 hat, beta 2 hat, beta 3 hat for the three variable model, you will get these normal equations, because n into beta 1 hat plus beta 2 hat sigma x2y plus beta 3 hat sigma x3y is equal to sigma yi, first normal equation like that. Now in deviation form, yi is equal to beta 2 hat x2y plus beta 3 hat x3y plus u hat. in deviation form, the three variable model, then the normal equations are sigma yi x2y is equal to beta 2 hat sigma x2y square plus beta 3 hat sigma x3y x2y. First normal equation. The second is sigma yi x3y is equal to beta 2 hat sigma x2y x3y plus beta 3 hat sigma x3y square. We have derived these normal equations earlier. You just go through our derivations in the context of multiple linear regression model. Then in deviation form, what is x transpose y is equal to sigma yi x2y sigma yi x3y x transpose y. And what is x transpose x is equal to sigma x2y square sigma x3y x2y sigma x2y x3y sigma x3y square. If you multiply this with the beta hats, you will get this part. Now as you can see, in the three variable model in deviation form, x transpose x is 2 by 2 matrix. In terms of original observations on x and y, it is a 3 by 3 matrix. So if you generalize, for the general k variable model, the order of the x transpose x matrix is k by k in terms of original observations on x and y. But in deviation form, for a k variable model, it will be k minus 1 by k minus 1. In terms of deviation form, for a k variable model with the k minus 1 explanatory variables, the order is k minus 1 by k minus 1. And you can practice this with the matrix algebra and also in terms of ordinary algebra. Now let us see how we actually derive beta hats. We consider the derivation of the vector beta hats in the context of a two variable model because it is more easy to derive the results. Now, in the two variable model, as I have just written, x transpose y is equal to sigma yi xi and x transpose x is equal to n sigma xi and sigma xi square. Now, and x transpose x beta hat is equal to beta 1 hat, beta 2 hat. Now, this is x transpose y, this is x transpose x beta hat. Now, what is x transpose x inverse? X transpose x inverse is equal to adjoint of x transpose x divided by determinant of x transpose x as we have derived earlier. This is the equation for the inverse. Now let us see what is adjoint of x transpose x. This is equal to sigma x square minus sigma x and n. And you know how the procedure for deriving the adjoints. Each element of the x transpose x matrix is replaced by its minor. Signed minor is cofactor. Transpose of the cofactor matrix is adjoint matrix. So first n is minor is sigma x square minor and the signed minor is cofactor. As it is a symmetric matrix, this transpose will be the same matrix. You just refresh my discussion on how we derive X transpose X inverse. Then this determinant of X transpose X is equal to n into sigma x square minus sigma x the whole square. N into sigma xi square minus sigma xi the whole square. So, what is beta hat? Beta hat is equal to 1 by n into sigma xi square minus sigma xi the whole square determined into X transpose X inverse. X transpose X inverse, that is into adjoint of X transpose X, that is sigma x square minus sigma x minus sigma x n into sigma yi xi. X transpose y sigma yi xi. This is equal to, you multiply this to this and divide with this determinant. So first sigma x square into sigma y minus sigma x into sigma xy divided by n into sigma x square minus sigma x the whole square. That is the first. Then sigma next is minus sigma x into sigma y minus n into sigma xy divided by n into sigma x square minus sigma x the whole square. That is beta hat. And as you know, beta hat is equal to beta 1 hat and beta 2 hat. So beta 1 hat is sigma x square into sigma y minus sigma x into sigma xy by n into sigma x square minus sigma x plus the whole square. Beta 2 hat is, you write this first. That is, this is what, minus plus. This is plus. So you write this n into sigma xy first. So n into sigma xy minus sigma x into sigma y divided by this. So beta 1 hat and beta 2 hat. So this is how we derive the OLS vector in matrix form. As you can see, the vector beta hat is X transpose X inverse X transpose Y. For the 2 variable model, this is the result. For the 3 variable model and for the k variable model, the result is the same, X transpose X inverse X transpose Y. Now you practice this in terms of matrix and also compare this with the results obtained in non-matrix form. And when you practice, always write down the order of this X, beta hat, etc. And remember this, the order of the Y matrix, X transpose X, X, everything is derived from the order of this. Y is n by 1, this is n by k, this is k by 1, this is n by 1. Always keep in mind the order of Y, the order of X, the order of beta, and the order of n. Then there will not be any confusion. And also, a little practice will give you more confidence in matrix approach.